So imagine a massive solar storm erupting, or, a Category 5 hurricane suddenly shifting its track right toward a major coastline.
Right, something where every single minute matters.
Exactly. And high above the Earth, there's this multi-billion-dollar constellation of satellites that instantly registers the threat.
Yeah, they have the raw data.
They have the data, right, the data that could, save thousands of lives and protect all our critical infrastructure. But, and this is the kicker, that data is completely useless if it can't actually get down to the ground.
Absolutely. It's just floating up there.
Right. We always tend to focus on the flashy hardware in orbit, but we completely ignore the fragile, incredibly complex tether that's keeping it all connected to us.
The ground antenna.
Yeah, the actual nervous system of our global environmental data. It relies on this vast, globally distributed network of physical ground antennas. And today, for this deep dive, we're looking at a stack of documents outlining how the U.S. government is frantically trying to rewire that entire nervous system.
And trying to do it before it collapses under its own weight, honestly.
Right.
The documents we brought into, so we've got the draft request for proposals and the statement of work for this massive initiative called NCAGSS.
Okay, let's unpack this. NCAGSS is what the NCAGSS Consolidated Antenna and Ground Systems Services.
Yeah, the one. And NCIS, for those who don't know, is the National Environmental Satellite Data and Information Service.
Which is a mouthful.
It is, yeah.
Yeah.
But these documents, I mean, they are an absolute masterclass in massive systems engineering. For anyone tracking this, you know the stakes here. They are basically attempting to pull this legacy, highly siloed infrastructure into a modernized dynamic architecture.
And backing it up with a $1.2 billion contract.
Exactly, $1.2 billion.
Which is just staggering. And I want to get into the money, but first, I mean, the sheer scale of the physical hardware managed under this contract is wild.
Oh, it's everywhere.
Right. It's not just sitting in a comfortable server farm in some, suburban tech park. You're dealing with the primary operations out of Suitland, Maryland, and this massive consolidated backup facility in Fairmont, West Virginia.
Yeah, but then the footprint extends way, way out.
Yeah, to Fairbanks, Alaska, Wallops Island, Virginia, and even McMurdo Station down in Antarctica.
Which is just crazy. I mean, the environmental extremes alone make this a total logistical nightmare.
I can't even imagine trying to keep a satellite dish running in Antarctica.
Right. But the technical diversity is actually where the real complexity lies. Because the statement of work, it outlines management for hardware ranging from these small, 2.4-meter dishes all the way up to massive 26-meter behemoths.
Wait, 26 meters? So that's roughly the length of a professional basketball court.
Yeah, a basketball court made of metal, pivoting to track objects, zooming through space at, thousands of miles an hour.
That's insane.
And they are capturing an absolute fire hose of data across multiple radio frequency bands. You've got S, L, X, Chi, and Q bands.
And each of those bands requires completely different hardware, right?
Oh, yeah. Totally different hardware calibration, different feed horns, different signal processing logic.
Yeah.
And the ground stations have to actively communicate with geostationary satellites, the ones hovering in one spot.
Right, GEO.
Yeah, GEO. Yeah. But also low Earth orbit, or LEO, the satellites that are just screaming across the horizon in these tight 10-minute windows. Plus, space weather operations assets positioned deep in space.
So historically, the engineering approach to all of this was incredibly bespoke, right? You launch a new satellite mission and you build a new dedicated dish on the ground specifically tuned for that single spacecraft.
Basically, yeah. One satellite, one dish.
But looking at the draft RFP, the mandate here is super clear. They are completely abandoning that model.
They have to. It doesn't scale.
Right. So they are shifting to what they call NESDIS antenna as a service. They want this shared multi-mission infrastructure.
Which is a huge paradigm shift for the government.
Yeah, I look at this and I think about, the shift from everyone having a dedicated physical landline in their house, a literal wire connecting you to the phone company.
Yeah, a very physical, rigid system.
Exactly. Moving from that to everyone sharing bandwidth dynamically on a modern cellular network.
That's actually a really good mental model. The cellular network analogy works perfectly for the dynamic allocation of resources they're going for here.
Because the old way was so wasteful, right?
Exactly. In the old bespoke model, a massive dish might literally sit idle for hours just waiting for its specific satellite to pass overhead.
Just doing nothing.
Right. But with NAI, the system is designed to seamlessly route incoming LEO passes, GEO data streams, space weather telemetry, whatever it is, through whatever hardware is actually available and capable in the network at that moment.
Wait, let me push back on that for a second.
Sure.
Because if you transition to dynamic sharing across fewer consolidated dishes, aren't you introducing a massive resource collision
What
problem?
do you mean?
Like, what happens when two critical weather satellites pass over the Fairbanks station at the exact same time, and they both desperately need a Ka-band downlink?
Ah, I see what you're saying.
If you've consolidated your hardware down, you've essentially created a bottleneck where some algorithm has to decide which satellite data gets dropped, right? That sounds super risky.
Well, if we connect this to the bigger picture, that perceived bottleneck is exactly why the architecture incorporates external commercial capacity.
Oh, okay.
Yeah, the contract explicitly pushes for integration with GSAS, which is Ground System as a Service.
Wait, meaning they aren't just relying on government-owned hardware anymore?
Right. By standardizing the back-end architecture, the system can instantly evaluate the incoming traffic, recognize, say, a collision at that Fairbanks station, and dynamically lease time on a commercial satellite dish.
Like a dish owned by a private space company.
Exactly. A private dish in a neighboring region. So you transform this rigid, single point of failure hardware network into a globally distributed elastic web. It dramatically increases the overall resiliency of the data flow.
Wow. Okay, but running an elastic, globally distributed web of both government and commercial hardware, I mean, that requires an insanely complex financial and administrative framework.
Well, the bureaucracy is intense.
You can't just hand a vendor $1.2 billion and say, hey, go figure it out.
Definitely not.
And looking at the draft RFP, the structure they've landed on is actually fascinating. It's an IDIQ contract, indefinite delivery, indefinite quantity.
Which is pretty standard for something this massive.
Right, and it spans a 10-year period. It has a ceiling of $1.239 billion. But, and this part made me laugh, the actual minimum guarantee baked into the contract is a hilariously low $250.
Yeah, the optics of a $250 minimum on a billion-dollar ceiling always look totally absurd to people outside the industry.
Sounds like a joke.
It does.
Yeah.
But it's the fundamental mechanism that makes an IDIQ work. Look, over a 10-year period, the government cannot possibly predict exactly how many antennas will need maintenance in, say, year 7.
Right.
Or what commercial GSAS rates will look like in 2030, or what entirely new satellite architectures are going to launch.
So they establish the absolute legal maximum they're allowed to spend, the ceiling,
Yep.
but the vendors only see real money when the government issues specific, isolated task orders for particular jobs.
Exactly. The IDIQ is essentially a pre-negotiated hunting license.
A hunting license. I like that.
It locks in the labor rates, the security clearances, and the overarching rules of engagement. So when a piece of hardware suddenly needs upgrading, or a new cloud integration is required, the government doesn't have to spend a full year going through a massive procurement cycle.
Because they've already done the paperwork.
Exactly. They just release a task order to the pre-vetted vendors who already hold the IDIQ.
And to manage those task orders, the contract is broken down into 4 distinct functional areas, right? Program integration, operations, maintenance, and sustainment.
Yes, the 4 pillars.
And they are allowing up to 5 different vendors to compete for the task orders in operations, maintenance, and sustainment.
Basically creating a mini market.
Right. But the program integration area is strictly awarded to a single vendor. And here's the kicker. It's the Organizational Conflict of Interest Clause, or the OCI.
Oh, the OCI is everything here.
The RFP explicitly forbids the company that wins the program integrator role from bidding on any of the other 3 areas.
Yeah, the OCI clause is literally the bedrock of the entire management strategy.
Which makes sense.
It does. The program integrator is responsible for the overarching systems engineering. They write the requirements, they evaluate the hardware performance, and they set the schedules.
So they're the boss.
Right. And if they were allowed to perform the actual maintenance or operations work, the incentive structure becomes incredibly toxic really fast.
It's the classic general contractor problem.
Exactly.
It's like you hire a general contractor to oversee the architectural integrity of a brand new skyscraper, but you legally bar them from using their own in-house plumbing or electrical teams.
Because otherwise they just grade their own homework.
Right. You have to maintain an absolute firewall between the entity setting the requirements and the entities executing the labor.
You're separating the referee from the players.
Yes. Otherwise, the integrator just feeds the most lucrative task orders to themselves and conveniently buries any performance failures.
Spot on. And to ensure that the program integrator is genuinely acting as this impartial top-tier referee, the government is utilizing the HTRO evaluation process.
Which stands for highest technically rated offers?
Exactly. They are making a massive calculation here that technical brilliance is vastly more important than cost savings.
Which is wild, right? Because the stereotype of government contracting is always lowest bidder wins.
Always.
So if they are tossing price to the side during the initial evaluation, they must be absolutely terrified of the technical risk involved in this transition.
Terrified is probably the right word. The technical risk is monumental. In Phase I of the HTRO evaluation, the government is essentially ignoring the price tag.
They don't even care.
Nope. They demand highly detailed, day one or sample task order proposals.
Which means what, practically?
It means the vendors can't just submit standard corporate marketing material or generic promises. They have to provide comprehensive engineering models showing exactly how they intend to manage a specific subset of the architecture from the very minute the contract goes live.
Wow.
Yeah, the government is willing to pay a premium to avoid the catastrophic failure of a vendor learning on the job.
And here's where it gets really interesting. Because the technical realities they have to manage under the sustainment functional area, they feel almost contradictory to me.
How so?
Well, the mandate is to aggressively modernize. They are forcing a transition to the NESDIS Common Cloud Framework, the NCCF.
Right, pushing everything to the cloud.
They are demanding agile methodologies, DevSecOps pipelines. They even require the use of digital twins and artificial intelligence for system monitoring.
Yeah, the deployment of digital twins in this environment is a massive paradigm shift.
It sounds like sci-fi.
It really does. Instead of taking a physical 26-meter antenna offline to test a new software patch, which you can't really do, the vendor creates a hyper-accurate virtual replica, a digital twin running entirely in the cloud.
Like a video game clone of the antenna.
Exactly. And they can simulate extreme weather events, inject malicious code, run stress tests on the virtual model to see how the system reacts.
All while the real one is still working.
Exactly.
Yeah.
All while the physical hardware continues downlinking critical data without a single second of interruption.
Okay, in a vacuum, digital twins and DevSecOps sound incredible.
Yeah.
But you are attempting to layer these cutting-edge cloud-native concepts over legacy physical hardware.
Very legacy hardware.
Right. In some cases, we are talking about satellite dishes and routing hardware that have literally been sitting in the salt air of Wallops Island for decades.
Oh, yeah. The rust is real.
And you have to do all of this under the crushing weight of a high-risk government cybersecurity classification. The statement of work mandates relentless vulnerability scanning, strict zero-trust architectures, and automated anti-malware deployments.
It's an incredibly aggressive cyber posture.
So I have to ask, isn't this like trying to install a modern smartphone operating system onto a 1998 rotary phone while actively fending off hackers? Like, how do you run an automated aggressive vulnerability scan on a system built 20 years ago? Doesn't that just crash the operating system?
It absolutely will crash it. You nailed it.
So what do they do?
The friction between modern cybersecurity mandates and legacy hardware is the single biggest point of failure in government IT modernization. And the statement of work actually acknowledges this reality head-on through something called the scanning exclusion list.
Okay, I saw that in the documents. How does that actually function in practice? Because it sounds like a giant loophole.
It's less of a loophole and more of a manual quarantine. The vendors have to audit the entire global infrastructure and identify the specific legacy components that are so fragile or bespoke that a standard automated cyber scan would just knock them completely offline.
They just fall over.
Right. So they put those components on the scanning exclusion list. But the government doesn't just give them a free pass.
They still have to secure it.
Exactly.
Yeah.
Once a system is on that list, the vendor has to dedicate highly skilled engineers to manually evaluate, patch, and secure that hardware using alternative, non-disruptive technical means.
So you're trading an automated software process for incredibly expensive, time-consuming human labor.
Exactly, which ties directly into the obsolescence prevention clause.
Oh, the obsolescence stuff is wild.
It really is. The contractors are contractually obligated to maintain this massive radar on the lifespan of every single microchip, server, and software license in the network.
Like tracking expiration dates on milk, but for microchips.
Yeah. They have to identify any component that is within 1 year of becoming entirely unsupported by the original manufacturer, and they have to engineer a replacement strategy before it dies.
And while they are doing all of this, running the manual cyber checks, predicting hardware death, implementing DevSecOps, they still have to adhere to the flaw remediation requirements.
Which is non-negotiable.
Right. They are in a perpetual sprint to patch zero-day exploits. But the SOW explicitly states they cannot cause a single second of downtime on critical weather days.
Not a single second.
So if you have an active hurricane in the Gulf of Mexico or a severe solar flare inbound, you cannot take the primary ground station offline to install a mandatory security patch.
No, the data flow supersedes the cyber update. Always.
So how does that work?
The operational tension is incredible. What's fascinating here is how they handle it. You have an inbound cyber threat requiring an immediate patch, but an active weather event prohibiting any system downtime.
An impossible situation.
Right. So the engineers have to leverage that redundant infrastructure we talked about earlier. They fail over the data streams to the backup facility in Fairmont, or they dynamically route it through a commercial GSAS provider, patch the primary system, and fail it back.
Wow.
All without dropping a single packet of telemetry.
That's just a ridiculous amount of pressure, which actually brings the entire conversation crashing down to the human reality of this whole thing.
The people on the ground.
Yeah. The abstract cloud architecture and the multi-million-dollar task orders ultimately rely on individuals sitting at consoles, often in highly isolated environments.
Absolutely.
When we look at the human resources and operational policies embedded in the draft RFP, the day-to-day reality of executing this 10-year contract is intense.
It requires a workforce that can operate under extreme technical pressure, but also strict bureaucratic oversight. The behavioral policies outlined for these deployments are incredibly rigid.
The section detailing the absolute prohibition of sexual harassment and assault stood out immediately to me.
Yeah, the SASH policies.
Right. It requires mandatory training within 30 days of onboarding, strict annual refreshers, and the deployment of a 247 SASH sexual assault and sexual harassment helpline.
Which is critical.
It is. And in a standard corporate office, that looks like, standard HR compliance. But when you apply it to the geographic footprint of this contract, it takes on a completely different weight.
The geographic context changes everything. I mean, you have contractors deploying to remote field camps, tracking ships in the middle of the ocean, or spending months at McMurdo Station in Antarctica.
You could literally be sitting at McMurdo staring at a satellite dish in the freezing cold.
Yeah. They are operating in physically isolated environments, living in tight quarters with the exact same small team day after day, in perpetual darkness or perpetual daylight, depending on the season.
It's like being on a submarine.
Exactly like that. In those high-stress, closed-loop environments, robust safety protocols and an anonymous direct lifeline back to corporate headquarters are critical infrastructure.
It's not just a poster on the break room wall.
No. The mission fails if the human element degrades.
And the human element also has to survive the brutal realities of government politics, too.
Oh, the shutdowns.
Yeah. Because this is a 10-year contract, a government furlough or a full budgetary shutdown is basically a statistical certainty.
Unfortunately, yes.
And the guidance in the documents for managing a shutdown is a massive headache for the contracting companies.
Well, when appropriations lapse, the work doesn't just uniformly freeze.
What happens?
The government dictates what is deemed accepted work.
Right.
If an engineer is physically operating the antenna array, pulling down telemetry from an active weather satellite, their function is critical to national security and public safety.
So they keep working.
They stay on the console regardless of the budget impasse.
But what about, the engineers handling the long-term cloud migrations or the teams building out the digital twin environments?
They are generally classified as non-accepted. They are legally forced to stop working and are sent home.
Wow. Just go home. We can't pay you.
Yep. And from a program management perspective, keeping a highly cleared elite engineering team intact while half of them are furloughed without pay due to political gridlock. It's one of the hardest things a prime contractor has to do.
I bet they just leave for other jobs.
Exactly. The talent bleed during a prolonged shutdown can totally devastate a long-term modernization effort.
And as if managing the talent pool wasn't hard enough, the prime contractors have to navigate the socioeconomic mandates of the federal government, too.
The small business quotas.
Yes. The RFP demands that the large prime contractors allocate at least 30% of the total contract value to small businesses.
And that 30% mandate is a really heavy lift, primarily because of how the government defines acceptable small business participation on a contract like this.
Right. The documents explicitly state that the primes cannot just hand off the low-hanging fruit.
No easy outs.
You can't just meet your 30% quota by subcontracting out, like the janitorial services, the landscaping, and basic administrative support.
Right. The government demands proof that the small businesses are being given meaningful, complex work that aligns with the core technical mission of the NCAGSS program.
Which has to be a management nightmare.
It is. Integrating a 15-person small business into a highly classified DevSecOps pipeline, or tasking them with maintaining a legacy Ka-band receiver array, it introduces massive management friction.
Because the big guy is still responsible.
Exactly. The prime contractor is ultimately on the hook for the system's performance. They have to mentor the small business, ensure their cybersecurity posture meets the Department of Commerce standards, and seamlessly weave their output into the broader NAICS architecture.
It's honestly a brilliant reflection of how government contracts operate.
They're never just about the tech.
No, they aren't just technical blueprints. They are sweeping mechanisms for social and economic policy.
Absolutely.
You're demanding cutting-edge cloud integration while enforcing federal labor laws, driving small business economic growth, and managing the psychological well-being of isolated workers in Antarctica.
Yeah, a billion-dollar balancing act.
And a failure in any one of those pillars, whether it's, a missed cyber patch, a collapsed subcontractor, or a hardware failure on a 26-meter dish, it just cascades through the entire system.
And we feel it here on the ground.
We do. So to everyone listening, the next time you're tracking a storm on your phone or checking a long-range forecast to see if a drought is going to break, I want you to think about the immense invisible machinery making that data possible.
It's easy to take for granted.
It really is. Behind that seamless digital experience is a $1.2 billion bureaucratic framework, thousands of engineers battling obsolete hardware, complex small business integrations, and the harsh realities of extreme environments, all working frantically to keep the data flowing from space down to your screen.
And, as we look toward the next decade of this infrastructure, this shift toward NAS and the heavy reliance on commercial GSAS providers leaves us with a critical strategic question.
Yeah.
Historically, the ground systems capturing our weather and environmental data were purely public assets, wholly owned and controlled by the government.
Yeah, paid for by taxpayers.
Exactly. But as NOAA increasingly leans on private corporate infrastructure to supplement their network, where is the line?
That's the big question.
At what point does the life-saving environmental data we rely on for national security stop being a public utility and start becoming inextricably dependent on the profit margins and operational priorities of private space companies? What happens when the public interest and corporate bottom lines collide in orbit?
Man, that is a profound question to chew on as the commercial space sector just continues to explode. Thanks for taking this deep dive with us. We'll see you next time.